Okay. So today's my lecture on rapidly variable. So before this lecturing, we have discussed seen on the topics of open channel flow. Then next thing is gradually verify. Then third thing is rapidly verify. So already we discussed on the last lecturing about the gradually verify and the rapidly verify. So once again, we have to recall this concept. What is the rapidly verify and what is gradually verify? So rapidly verify will occur over the long length of the channel. When the water is flowing through a channel in a channel, it will occur at long distance. When it is occur at a long distance, then the flow is said to be a gradually verify. In rapidly varied flow, the flow depth will, in which the depth of flow will changes over the length of small length of the channel. So it will get a changes of depth over the small length of the channel. So then it's said to be a rapidly varied flow. So this is the definition for this rapidly varied flow. Okay. So here we have number of jump that is occur in a open channel. So what type of jump will occur? So when it jump will create and how to calculate the hydraulic jump and this jump can be classified into three types. That is flow will be classified into three types. So the one is critical flow, subcritical flow, supercritical flow, then transaction flow. So those are the categorized by using the formula of root number. Okay. So consider the flow of water in a dam. Okay. So how the water is from the upstream side to the downstream side, flowing of water from the upstream side to downstream side. The height of the water section one is small, and as this move towards the downstream, the height of the depth of water increases rapidly over the short length of the channel. So then these type of section one will comes under the flow of subcritical flow. When the depth is subcritical flow, as the depth one is less than the critical depth. So subcritical flow is always an unstable flow. So we say the subcritical flow is always an unstable flow and does not continue on the downstream side. Thus, these supercritical flow will convert itself into a subcritical flow. Hence, the depth of water will increases. The sudden increase of depth of water is called hydraulic jump or a standing wave. So, how sudden increase of depth will create this hydraulic jump or standing wave? So, hydraulic jump will have the another name, that is a standing wave. Okay. So here the definition will be given as the same. The hydraulic jump is the phenomenon that occurs where there is an upward transition from the supercritical flow to subcritical flow. The most important factor that affects the hydraulic jump is Froude number. So here the most important factor that affects the hydraulic jump is called Froude number. Froude number, we can find this Froude number value. Based on this Froude number value, we can say the flow is subcritical, supercritical, or a critical flow. When the F value is greater than 1, that is supercritical flow. Less than 1, subcritical flow. F is equal to 1, that is called critical flow. Where it will occur, it means that when the water from the dam will get out to the outstream in the outstream point, these type of hydraulic jump will occur. Okay. So the most typically location of the hydraulic jump are jump below the sluice gate, jump at the toe end of the spillway. So in here, the toe end of the spillway, it means that what is the spillway? So we have to know the idea about, get the idea about the spillway. So generally the excess of water from the reservoir or a dam can get out through by the spillway. This spillway, then water will come out from the spillway from the dam. The jump will be created in an enormous way. So that, at that point also the hydraulic jump will may occur. Then jump at glasses. So here also jump hydraulic jump may occur. Then glacis is the name of sloping floors provided in a hydraulic structure. So how the glacis will be provided in a hydraulic structure. So this is the definition for the hydraulic jump. So in hydraulic jump, this type of jump is defined as sudden increase of depth of water. That is a sudden increase in the depth of water due to the transformation of unstable supercritical flow to the stable subcritical flow. So where this transaction state will lies? The transaction state will lies in an unstable critical flow to transformation will create in an unstable supercritical flow to stable subcritical flow. So this point is called as transaction state. So where it get in a change of water from this one portion to another point. When hydraulic jump take place, a loss of water due to the eddy formation or turbulence will occur. Okay. So some part of energy may get lost. Okay, some energy may get lost. That is called as eddy formation or turbulence will occur. Turbulence will occur means there is a large amount of distraction in the water. So where the water flowing in the part, the water gets some distraction. So due to this jump occur and may resulting in loss of the energy. That is a loss of energy. Okay. So this is the definition for this hydraulic jump. So this is the picture which shows that how the jump will created from various examples. Already we seen in previous slide about so how the water from the upstream to the lower stream, then how the water jumps from the glacis, then how the water will form in a spillway. So these all the things are discussed in the previous slide. So same thing, the jump from the sluice gate. How the jump when it is this portion we have to note it as a sluice gate. Then how it the jump will be fall down like this. Then created a jump is called jump below the sluice gate. Then this is the jump like a glasses. Then this is the jump at the toe end of the spillway. So next, so what are the assumption general expression for hydraulic jump and what are the assumption has been made in a hydraulic jump? Okay. So general expression may express that how this hydraulic jump will occur and what are the assumption has been made. In analysis of hydraulic jump, the following assumptions are made. The length of the hydraulic jump is always small. Consequently, loss of it due to the friction is negligible. When the hydraulic jump is small, length of the hydraulic jump means the creation of hydraulic jump is small. There may be a losses of it due to the friction is negligible. There is no loss of energy due to the friction will get into the reduced in numbers. Okay, so the flow is uniform. Next point is the flow is uniform. Then next another thing, the flow is here. The flow is uniform one. Then pressure distribution is due to hydrostatic before and after the jump. Here the pressure distribution also uniform. The flow is uniform. Pressure distribution is also uniform before and after the jump. Then slope of the bed channel is very small, so that the component of weight of the fluid in the direction of flow is neglected. So these are the assumption has been made, and this is the equation has been derived that which shows that how the jump equation. So before that, there must be there will be some available applications of use of hydraulic jump. Okay, so hydraulic jump, it is a useful means of dissipating the excess energy of water. Dissipating means removing the excess energy of water flowing from spillway and other hydraulic structure. It raises the water level in the channel for irrigation purposes. Then due to the increase in the depth of flow, the uplift pressure acting on the apron is considerable countered balanced. It increases the discharge through the sluice. It increases the discharge through the sluice. When a jump will created, it creates the discharge through the sluice. It is used for mixing of chemical in water and liquid due to the turbulent is created in a jump. Already we know that what is the laminar and what is turbulent. When it is possible and easy one for creating them turbulent in a water. Okay, then useful in the efficient operation of flowing of hydraulic fluids. Okay, then next thing, the application of this momentum equation for the rapidly varied flow in the dry deriving the depth. So this is the equation which we have been derived from the GVF, that is from the momentum equation for the rapidly varied flow. So here we have few assumption has been made, that are the assumption we have discussed in the previous slide. So based on that assumption, we have this momentum equation. In this momentum equation, we finally conclude with the so how the pressure will acted from the one side and how the pressure reacted from the another side. Okay, so pressure force at the section 1 and pressure force at the section 2, then friction, then initial depth, then final depth, then subsequent depths, how it's all created in a channel. So these are the applications and applying of the momentum equation in a. Okay, so this is the specific energy. So we says the specific energy where the curve will be the minimum, then the portion is called as specific energy. So here specific energy curve will be like this. This curve is called specific energy curve. Okay. So next, different types of hydraulic jump will have. So the angular jump, weak jump, oscillating jump, steady jump, and strong jump. So how we can calculate these type of jumps? It means that the Froude number value, which is 1 less than 1.7, the undulation on the surface is called as. So based on the Froude number value, the class jump may be classified into the following types. Then weak jump, here the Froude number value is 1.7 to the range of 2.5. It lies between 1.7 to 2.5. So then we said this jump is called as weak jump. Here, uniform velocity will occur. Energy losses is small. Small rollers, that is roller means rolling of water, no baffles. Then downstream water surface is smooth. So these will occur in a big jump. So when we come into the point of oscillating jump, the Froude number values lies between 2.5 to 4.5. Water get accelerating back when water move in a direction and it will get reversed due to this jump. And fourth, from bottom to the surface. Then steady jump, where the steady jump occurs. In a Froude number value, the steady jump will occur between the 4.5 to 9. The position is sensitive to the variation of tailwater. The efficiency is 45 to 70%. This will happen in a steady jump. For a strong jump, the Froude number value is greater than the 9. This jump will create an enormous amount of releasing of energy from a water. This type of strong jump will be created. When the Froude number value it is the strongest jump, so then it called a strong jump. When the Froude number value is greater than 9, the efficiency is around 85%. Here we get. So these type of jump is called as strong jump. So these are the categories, how the jump will created in the water while flowing. Okay, so that's all about these topics, and thank you for the wonderful session.